Good morning, 7th graders. We have the last part of 9.2 to cover, and we're going to do the quotient property of square roots. And it's similar to the product property, but we're going to be using division, and it's going to be in the form of a fraction. So for the quotient property of square roots, we're going to start with our definition in algebra. So we have the square root of a over b, and this is going to be the same as the square root of a over the square root of b. So kind of similar to the product property, we're going to be breaking it up into each of those pieces. Now we have to make sure that a is always greater than or equal to 0 because we can't have the square root of a negative number. And b has to be greater than 0 because again we can't have the square root of a negative number. And b can't equal 0 because we can't have 0 in the denominator of a fraction. What this is going to look like with numbers would be a fraction under the square root sign, so we'll use 11/4, and this is the same as the square root of 11 over the square root of 4, and if we look at this, we can't simplify the square root of 11, but we do know the square root of 4 equals 2, so that would be the most simplified version of this fraction. We're going to do a pretty simple example. If we have the square root of 13 over 36, we're going to use the quotient property, so it'll be square root of 13 over the square root of 36. We don't know the square root of 13, so that stays the same, but we do know the square root of 36 equals 6. So that would be your final answer. Like always, we need to make it a little bit harder, so we're going to do another example, and we're going to throw in an extra step of needing to simplify. If our next example was the square root of 27 over 4, we're going to need to go ahead and simplify this. If you already know what you should do, go ahead and do it. If not, just follow along. So for the numerator, we're going to have the square root of 27, and the denominator would be the square root of 4. And we're going to do it one step at a time, so we're going to start with the denominator because we should easily see that that can be simplified. So the square root of 4 is 2, so 2 is in our denominator, and then we can start to look at the numerator. And hopefully you've noticed that 27 is divisible by a perfect square, and it's 9, so we're going to also use the product property within our quotient property. So we keep the same denominator, and our numerator we're going to change to the square root of 9 times 3. So that equals the square root of 9 times the square root of 3 all over 2. So then our final answer, we know the square root of 9 equals 3. It's being multiplied by the square root of 3. And the whole thing is over 2. So this is going to be your final answer. I'm going to let you try the next one on your own. So the next one is going to be the square root of 180 over 49. Oh, make that a 9. Okay, so we're going to go ahead and pause the video. That way you can try and solve it on your own, and then you can check your answer, and I'll go over all of the steps in a second. Okay, so let's go ahead and split it up. We've got the square root of 180 over the square root of 49. We can go ahead and simplify the denominator. The square root of 49 equals 7, and we're left with the square root of 180 in the numerator. And then from there, we're going to look and see what we can break 180 up into. If it's easy for you, you can do some side work. So the square root of 180, an easy way to do this, we could start with 9. Or, well, you could start with 9. You could also start with 4, but we're going to do 9. So this is the same as 9 times 20. The square root of 9 is 3. We have the square root of 20. So the square root of 20 is the same as 4 times 5. So we have 3 times the square root of 4 is 2, and we have the square root of 5 left over. So So we have 6 square roots of 5. So we can go back up to the top. We have square root of 180 is the same as 6 square roots of 5 over 7, and you just double check, make sure that nothing else can be simplified, and then you'll be finished. The last thing we're going to do is throw in some variables. So if we have the square root of 32 over n squared, go ahead and break it up into the 2 parts, numerator and denominator. We'll simplify the denominator. The square root of n squared equals n. And the numerator, we need to look at it and see if there's anything that is a perfect square that we can multiply and get 32. And you should hopefully notice either the perfect square of 4, or we're also going to have 16. And I think that's probably an easier one to use because we can do that in one step. So we have 16 times 2. The square root of 16 equals 4, and we're left with the square root of 2 all over n. So again, you're going to have one more problem to try on your own, and then I'll go over the answer. Your last problem to try on your own is going to be the square root of 75x cubed over 16. So we'll go ahead and break that up. Square root of 75x cubed, square root of 16, and then simplify. The square root of 16 we know is 4, and then we'll work with the numerator. So let's do a little extra side work just so that we don't have so many steps all in one area. So 75x cubed. We're going to break that up into 75 and the square root of x cubed. And the square root of 75, that's the same as 25 times 3. And we're going to bring down the x cubed. So the square root of 25 equals 5. We're left with the square root of 3. And we're going to break up x cubed into x squared. Oh, we got a little... Got to undo that line. Okay. X squared times x. Now, the x squared, we can go ahead and simplify that. So, we'll move on over 5 square roots of 3. The square root of x squared equals x. And we're left with the square root of x under the radical. And we're going to go ahead and move everything around. So, 5x... square root of 3, square root of x, and we're going to combine these two back together. So 5x times the square root of 3x. So that's going to be our new numerator. All over 4. So double check your answer, make sure that there's nothing else that can simplify. Sometimes you might find that you can simplify the numerator with the denominator, which we can't do. But so this one looks good. That's our final answer.